Hi, today we're going to evaluate this enormous sum, and at first glance, it looks pretty daunting and there's a lot going on, but really this is just a sheep in wolf's clothing. This is pretty tame at the end of the day to deal with. Well, how can we add up all these terms? There's got to be some sort of method here that we can employ. Well, the key is to look at the structure of each term. So let's do that first. The structure of each term looks something like this. So notice, starting from 3 in the numerator, we go up by 1 each time. 4, then 5, 6, 7, all the way to 2023. And in the denominators, we have 3 factorials. So starting with 1, 2, and 3 factorial, then 2, 3, 4 factorial, and so on, all the way up until 2021, 2022, and 2023. Well, the pattern that we see is, in the denominators, we start with this number here, let's say k. So k factorial. And to that we add one number higher factorial. So we add k plus 1 factorial. And then to that we add 1 higher, and so we have k plus 2 factorial. But in the numerator, this number matches the last of the trio downstairs. See, the number in the top matches the last of the trio downstairs. So there we have a k plus 2. So each term looks like this. Okay, well that's fine. So if we can just simplify this and see if it can take us anywhere, we'll be in business. The first thing we can do is take the denominator and factor out a k factorial. When we do that, this term leaves us with 1. Then this, k plus 1 factorial, is just k plus 1 times one number lower than that, k factorial. So from k factorial onward, that cancels with what we have outside the brackets. So we're left with k plus 1. But then k plus 2 factorial, that's k plus 2 times k plus 1 times k factorial. And that cancels out with this. So all that's left is k plus 2 times k plus 1. Well, that's great. But notice right here, 1 plus k plus 1, that's k plus 2. So if we take that as a hint, we have a common factor, k plus 2 here and k plus 2 here. Let's factor that out in the denominator. So we have k plus 2 in the numerator, then k factorial downstairs, and now we're factoring out a k plus 2. And then what we have left inside is 1 from here plus k plus 1 from there. But now this quantity is again k plus 2. So what can we do with this? Well, first of all, there's this k plus 2 upstairs and a k plus 2 downstairs. We'll just cancel those out. But at the same time, we're going to multiply this fraction by k plus 1 divided by k plus 1. Why is that? Well, take a look at this. In the numerator, we have k plus 1. In the denominator, we have k factorial times k plus 2 times k plus 1. Well, let's write that a little more cleverly. Let's write k plus 2 first, then k plus 1, then k factorial. Well, k plus 2 times k plus 1 times k, etc., k factorial, this is just k plus 2 factorial. So having said that, we now have k plus 1 divided by k plus 2 factorial. But if we make one more move here, k plus 1, we can rewrite this as k plus 2 minus 1. That's still k plus 1. And when we do that, we end up with the following. Let's bracket off the k plus 2 and write that over our k plus 2 factorial. minus this 1 over the k plus 2 factorial. Having done that, the first fraction simplifies. The k plus 2 upstairs and the 1 downstairs cancel. So we're left with 1 in the top, and then, well, k plus 1 factorial downstairs. Minus 1 over k plus 2 factorial. Okay, good. So this series here, this sum, any one term can be expressed like this, but when we simplify that, it actually looks like this. So how does this help us? Well, let's take a look. Let's look at the first few terms of this series. When k equals 1, that corresponds to the first term of the series, where this k is 1. So what does that give us? Well, 1 over 1 plus 1 factorial minus 1 over 1 plus 2 factorial. And that's nothing more than 1 over 2 factorial minus 1 over 3 factorial. How about when k is 2? So that'll correspond to this next term. So when the k is 2. Well, we have 1 over 2 plus 1 factorial minus 1 over 2 plus 2 factorial. But that's 1 over 3 factorial minus 1 over 4 factorial. Let's write out another term. When k equals 3, well, now we have 1 over 3 plus 1 factorial minus 1 over 3 plus 2 factorial. But that's just 1 over 4 factorial minus 1 over 5 factorial. Okay, perfect. Now we can go on, of course. And eventually we have to stop when this k value is 2021. So when k is 2021, writing it in this form, we have 1 over 2022 factorial minus 1 over 2023 factorial. Okay, good. So if we sum up all these terms, here's what we get. This plus this plus this plus all the way up to this. Now here's the beauty about this. This telescopes wonderfully. These two terms cancel with each other, and then the next two neighboring terms cancel with one another, and then of course this will continue. This will cancel with its neighbor, and this will cancel with its neighbor just prior. So all that's really left is two terms in this series. We're left with this very first quantity here and this very last one. So that tells us that our sum is 1 over 2 factorial, that's a half, minus 1 over 2023 factorial. Well, this is very hard to compute. This is a nice exact form to leave it in. So the sum for this entire series here is just 1/2 minus this really tiny number here. And there we have it. We've evaluated our sum. Thanks for watching.